Opening hook, the young woman stared at the ceiling of her hospital room, paralyzed from the neck down after a devastating car accident. The doctors had delivered their prognosis with clinical detachment. She would never walk again. Yet 3 years later, Felicity Dawson stood on a podium receiving a medal for completing a marathon. Her medical team called it a miracle. Neuroscientists called it neuroplasticity. Felicity called it a conversation, one she had learned to have with her own body. "They told me my spine was severed," she would later explain. "But no one told me that my mind could build new pathways. No one mentioned that my thoughts could literally reshape my physical reality." What if everything you have been taught about the separation between your mind and body is fundamentally wrong? What if the boundary between thought and physical matter is not a wall but a permeable membrane, a dynamic, two-way street of molecular messengers, electrical signals, and quantum interactions that science is only beginning to comprehend? Consider this: when you merely imagine lifting your arm, the same motor neurons fire in your brain as when you actually lift it. When you visualize practicing a musical instrument, your brain forms the same neural pathways as physical practice. When you feel intense fear, your immune system immediately alters its function. These are not metaphors or poetic exaggerations. They are measurable, documented physiological responses that challenge our most basic assumptions about where mind ends and body begins. Set up, the artificial separation of mind and body runs deep in Western thinking. René Descartes, the 17th century French philosopher, famously proclaimed, "I think, therefore I am," establishing a dualism that placed mind and body in separate realms. This Cartesian split became embedded in modern medicine, which developed a mechanical model of human health. The body as machine, physicians as mechanics, symptoms as mechanical failures to be fixed with physical or chemical interventions. Dr. Isaac Greenberg, a neurobiologist at Cambridge University, explains the historical context. Medical education still largely follows this split. We teach organ systems as isolated units. We separate psychiatry from other medical specialties. We focus on disease rather than wellness. And most critically, we rarely discuss how thoughts, emotions, and beliefs directly affect physical processes at the cellular level. This separation was reinforced by technological limitations. Until relatively recently, scientists lacked the tools to observe how thoughts and emotions manifest in physical changes throughout the body. The brain remained a black box, its operations mysterious and seemingly separate from bodily systems. The first significant crack in this paradigm came in the 1970s with the work of Dr. Herbert Benson at Harvard Medical School. Studying practitioners of transcendental meditation, Benson documented what he called the relaxation response, a measurable physiological state characterized by decreased oxygen consumption, reduced blood pressure, and slower brain waves. Here was concrete evidence that mental activity could produce specific, measurable changes throughout the body's systems. Around the same time, candid cancer patient Norman Cousins published his groundbreaking account of using laughter as medicine. After being diagnosed with ankylosing spondylitis, a painful spinal condition with poor prognosis, Cousins checked himself out of the hospital and into a hotel room, where he consumed comedy films and humor books. He reported that 10 minutes of genuine belly laughter would give him 2 hours of pain-free sleep. His physician documented measurable decreases in his sedimentation rate, indicating reduced inflammation. Cousins ultimately recovered far beyond medical expectations. The medical establishment largely dismissed these cases as anomalies or placebo effects. But a small group of researchers began asking more profound questions. What if the placebo effect itself wasn't just a statistical nuisance in clinical trials but a window into the mind's capacity to influence physical healing? In 1983, psychologist Gene Achterberg and immunologist George Solomon independently published studies showing correlations between mental imagery and immune function. Patients who visualized their immune cells actively fighting disease showed increased numbers and activity of natural killer cells compared to control groups. These early pioneers faced fierce skepticism. Dr. Candace Pert, who discovered opiate receptors in the brain in 1972, found herself increasingly marginalized as she pursued the connections between emotions and biochemistry. The resistance wasn't just scientific caution, Pert would later write. It was almost theological. as if we were challenging a sacred boundary between mind and matter. The turning point came with the advent of functional magnetic resonance imaging, fMRI, positron emission tomography, PET scans, and other technologies that could observe the living brain in action. Suddenly, scientists could watch thoughts and feelings as they manifested in neural activity. The mechanical barrier between the intangible mind and physical brain began to dissolve before their eyes. But even these breakthroughs only hinted at the deeper question. How exactly does consciousness, this subjective experience of being, emerge from or interact with physical matter? And how deep does this interaction go? The deepening mystery in 1993, a landmark experiment at the University of Wisconsin, would fundamentally alter our understanding of the mind-body connection. Neuroscientist Richard Davidson invited experienced Buddhist monks to his laboratory to have their brains scanned while meditating. The results were astonishing. During meditation on compassion, the monks showed dramatic increases in gamma wave activity, some of the highest levels ever recorded in humans. Gamma waves are associated with higher cognitive functions, including perception, problem-solving, and consciousness itself. The monks could voluntarily produce these brain states at will, demonstrating a level of mental control over brain function that Western science had previously considered impossible. What we witnessed wasn't just unusual brain activity, Davidson explained. It was evidence that long-term mental training fundamentally alters brain function and structure. The mind was literally reshaping the brain. But the implications went far beyond the brain. Subsequent studies showed that these same monks could control their body temperature to the point of drying cold, wet sheets wrapped around their bodies in freezing temperatures. They could significantly reduce inflammatory responses to stressors. They could maintain metabolic stability under conditions that would cause physiological distress in untrained individuals. These abilities weren't supernatural, they were testable, reproducible physiological responses that challenged fundamental assumptions about the limitations of conscious control over bodily functions. Around the same time, a different line of research was revealing another dimension of the mind-body relationship. Psychoneuroimmunology, PNI, the study of how psychological processes influence the nervous and immune systems, was producing evidence that emotions weren't just subjective experiences but physical events with profound consequences for health. Dr. Francine Davenport, an immunologist at Johns Hopkins University, explains, "We discovered that immune cells have receptors for neuropeptides, the chemical messengers previously thought to exist only in the brain. This means immune cells can listen to the chemical language of thoughts and emotions. Your white blood cells are quite literally eavesdropping on your feelings." This finding revolutionized our understanding of how stress impacts health. When you feel threatened or anxious, your hypothalamus releases corticotropin-releasing hormone, triggering a cascade of physiological changes. Your adrenal glands secrete cortisol and adrenaline. Your heart rate increases. Blood is diverted from your digestive system to your muscles. Your immune system temporarily suppresses long-term defensive functions to prioritize immediate survival. This stress response evolved as a short-term survival mechanism, perfect for escaping a predator. But in contemporary life, stressors are often psychological and persistent. The mortgage payment, the difficult boss, the troubled relationship. When stress becomes chronic, this same survival mechanism becomes destructive. Prolonged stress response is like constantly revving a car engine, explains Dr. Greenberg. Systems wear down. Telomeres, the protective caps on chromosomes, shorten more rapidly, accelerating cellular aging. Inflammatory processes increase, damaging tissues. Gene expression changes, affecting how your DNA manifests in physical form. These aren't vague correlations. They're specific biochemical pathways through which thoughts and feelings become physical reality within your body. A 2013 meta-analysis examining 300 studies over 30 years found that chronic stress increases susceptibility to viral infections, slows wound healing, impairs antibody response to vaccines, and reactivates latent viral infections like herpes. But if negative thoughts and emotions can damage physical health, could positive mental states enhance it? This question led to one of the most controversial areas in mind-body research, the effect of prayer and intention on physical outcomes. In 1988, cardiologist Randolph Bird conducted a double-blind study of 393 heart patients at San Francisco General Hospital. Patients were randomly assigned to a prayed-for group or a control group. Neither the patients, doctors, nor nurses knew which group any patient belonged to. The results showed that the prayed-for group had fewer complications, needed fewer antibiotics and diuretics, and experienced less pulmonary edema. The study ignited controversy. Critics questioned methodology and raised concerns about confirmation bias. Subsequent studies have shown mixed results, with some supporting Bird's findings and others failing to find significant effects. The debate around prayer studies reveals our discomfort with phenomena that don't fit neatly into our materialist paradigm, says medical anthropologist Dr. Irving Gonzalez. But whether or not distant intention affects physical outcomes, we've confirmed beyond doubt that one's own mental state profoundly influences one's physical health. This influence extends to the genetic level. Epigenetics, the study of how behaviors and environment influence how genes work, has revealed that gene expression can change based on experiences, including psychological ones. In a groundbreaking study at Harvard Medical School, researchers demonstrated that practicing mindfulness meditation, yoga, or similar relaxation techniques for just 8 weeks produced measurable changes in gene expression. Specifically, they observed increased expression of genes associated with energy metabolism and insulin secretion, and reduced expression of genes linked to inflammation and stress response. We're not changing the genes themselves, clarifies epigeneticist Marcia Kaufman. We're changing which genes are activated and when. It's like having a full piano keyboard where different experiences determine which keys get played. This means that identical twins with identical DNA can develop different health outcomes based partly on their mental and emotional experiences. It also suggests that psychological interventions might literally change how your genome expresses itself. A profound challenge to the notion that our genetic inheritance is fixed and deterministic. Perhaps most remarkably, these genetic effects appear to extend beyond our individual lifespans. Animal studies have demonstrated that stress experiences can create epigenetic changes that are passed to offspring. Mice traumatized by electric shocks developed altered gene expression in sperm, and their offspring showed heightened anxiety behaviors despite never experiencing trauma themselves. Human studies suggest similar patterns. Children of Holocaust survivors show altered cortisol patterns and stress hormone receptor sensitivity, correlating with their parents' PTSD symptoms. While environmental factors certainly play a role, the emerging field of intergenerational trauma research suggests that intense psychological experiences may leave biological imprints that span generations. We're beginning to understand that the boundary between mind and body isn't just permeable within our individual lives, says Dr. Gonzalez. It may be permeable across generations. Your grandmother's psychological experiences might be influencing your physiology right now. If this sounds unbelievable, consider the concrete mechanisms involved. Stress hormones can cross the placental barrier during pregnancy, affecting fetal development. Parental behaviors shaped by their psychological experiences influence infant brain development during critical periods. And epigenetic markers on sperm and egg cells can carry information about environmental conditions, including psychological stressors. But perhaps the most profound challenge to the traditional mind-body division comes from an area once considered the most physical and least psychological, the digestive system. The turning point when Ian Green was diagnosed with treatment-resistant depression at age 27. He had exhausted conventional options. Multiple antidepressants, cognitive behavioral therapy, and even electroconvulsive therapy had failed to lift his persistent despair. I felt like my brain was broken, he recalls. I couldn't imagine any connection between my gut and my mental state. Yet his psychiatrist, Dr. Michael Kwan at UCLA Medical Center, suggested an unusual approach, a complete overhaul of his gut microbiome, the trillions of bacteria living in his digestive system. 10 years ago, I would have considered this fringe medicine, Dr. Kwan admits. Today, it's supported by some of the most exciting research in neuroscience. Over 8 weeks, Ian eliminated processed foods, sugar, and artificial ingredients. He added fermented foods like kimchi and kefir. He took specific probiotic strains shown to reduce anxiety and depression in clinical trials. He adopted intermittent fasting to reduce intestinal inflammation. The results were transformative. By week 6, it was like a fog lifting, Ian says. I kept waiting for the crash, the return of depression. It's been 3 years, and I'm still waiting. Ian's experience reflects a revolutionary new understanding. Your gut is quite literally your second brain, containing more than 100 million neurons, more than in your spinal cord. This enteric nervous system communicates bidirectionally with your central nervous system through the vagus nerve, forming what scientists now call the gut-brain axis. We've discovered that gut bacteria produce neurotransmitters like serotonin, dopamine, and GABA, the same chemicals targeted by psychiatric medications, explains neurogastroenterologist Dr. Eliza Sandoval. In fact, about 95% of your body's serotonin is produced in your gut, not your brain. This revelation has profound implications for how we understand mental health. Multiple studies have shown that germ-free mice, raised in sterile environments without gut bacteria, display abnormal stress responses, altered brain development, and anxiety-like behaviors. When these mice receive fecal transplants from mice with healthy microbiomes, their behavior normalizes. Human studies show similar connections. Patients with major depression showed distinctive alterations in gut bacteria composition compared to non-depressed controls. When rats receive fecal transplants from depressed humans, they develop depression-like behaviors. Conversely, certain probiotic strains demonstrate antidepressant and anxiolytic effects comparable to pharmaceutical interventions in randomized controlled trials. What's remarkable is the specificity, notes Dr. Sandoval. Different bacterial strains affect different aspects of brain function. Lactobacillus rhamnosus influences GABA receptors. Bifidobacterium longum alters vagal nerve signaling. Bacteroides fragilis impacts dopamine production. We're discovering that specific bacterial combinations can target specific psychological symptoms. This research transforms our understanding of the relationship between physical and mental health. Conditions once considered purely psychological are increasingly linked to inflammatory processes, immune dysfunction, and microbiome imbalances, all physical phenomena influenced by, but distinct from, mental activity. Dr. Greenberg puts it bluntly, the separation between psychiatry and the rest of medicine is a historical accident, not a reflection of biological reality. Depression isn't just in your head. It manifests throughout your body as altered inflammation markers, hormonal changes, and microbiome disruptions. Similarly, physical conditions like irritable bowel syndrome involve altered brain activity and stress processing. This perspective helps explain why traumatic experiences increase vulnerability to autoimmune diseases, why chronic pain often coexists with depression, and why psychological stress can trigger flare-ups of conditions from psoriasis to multiple sclerosis. It also explains phenomena once dismissed as psychosomatic. When patients with conversion disorder lose limb function despite no detectable nerve damage, they aren't faking or imagining their symptoms. Brain imaging shows altered connectivity between regions controlling emotional processing and motor function. The symptoms are real physical manifestations of altered neural circuitry, which can be reshaped through both psychological and physical interventions. Perhaps most remarkably, this understanding reveals why energy-healing practices like acupuncture, dismissed for decades as placebo effects, sometimes produce measurable physiological outcomes. While traditional explanations involving qi or life energy lack scientific validation, research shows that acupuncture affects inflammatory markers, endorphin release, and autonomic nervous system function through well-mapped neural pathways. The placebo effect itself deserves reconsideration, argues Dr. Davenport. We treat it as a nuisance in clinical trials, but it's actually one of the most robust phenomena in medicine. When a patient believes they'll heal and they do, that's not a failure of science. It's a demonstration of mind-body connection that we should be studying intensively. This reconceptualization extends to the realm of physical performance, where mental factors demonstrably influence capabilities once thought purely physiological. When Olympic athletes visualize their performances in granular detail, feeling the texture of equipment, hearing ambient sounds, sensing muscle tensions, they activate many of the same neural pathways used during physical performance. This mental rehearsal strengthens actual motor capabilities through established neuroplastic mechanisms. It's not metaphorical. It's a literal reshaping of physical neural architecture through directed mental activity. Similarly, studies of the nocebo effect, adverse effects caused by negative expectations, show that subjects who believe they've received a stimulant exhibit increased heart rate, blood pressure, and cortisol levels even when given an inert substance. The expectation alone creates measurable physiological changes consistent with the anticipated effect. These aren't fringe observations, emphasizes Dr. Greenberg. They're documented in peer-reviewed journals by researchers at institutions like Harvard, Stanford, and Johns Hopkins. What's surprising isn't the evidence, but how rarely it's incorporated into mainstream healthcare and education. Consider what happened when researchers tested two groups of hotel housekeepers. Both groups performed identical physical work cleaning hotel rooms. But only one group was informed that their daily work constituted exercise that met recommended guidelines for physical activity. For weeks later, the informed group showed decreased body weight, blood pressure, and waist-to-hip ratio compared to the control group, despite no changes in actual physical activity, diet, or lifestyle. Simply reframing their perception of their activity changed their physiological response to identical work. This demonstrates what researchers call mindset effects, how our beliefs and expectations about physical activities modify their physiological impacts. Studies show that people who consider themselves less fit than peers, regardless of actual fitness, have a 71% higher risk of death from cardiovascular disease. Hotel housekeepers who don't perceive their work as exercise show fewer fitness gains from identical physical exertion compared to those who recognize it as exercise. Elderly subjects who hold positive perceptions about aging live an average of 7.5 years longer than those with negative perceptions. These aren't just interesting correlations, Dr. Davenport explains. We've identified specific mechanisms. Stress perception affects telomere length and cellular aging. Expectation influences endocannabinoid release during exercise, affecting how much pleasure you derive from movement. Belief about medication efficacy changes brain activation patterns in pain processing regions. Even vision, seemingly the most objective of physical senses, is shaped by mental processes. When shown ambiguous visual stimuli, people literally see different physical realities based on their expectations and previous experiences. This isn't metaphorical. fMRI studies show different patterns of neural activation in visual processing areas based on what subjects expect to see. Your brain isn't passively recording external reality, explains vision researcher Dr. Samuel Park. It's actively constructing your perceptual experience, filtering raw sensory data through expectations, memories, and beliefs. In a very real sense, what you think influences what you physically see. This understanding reveals why mindfulness practices demonstrate measurable effects on conditions from hypertension to psoriasis. By changing attention patterns and stress responses, these practices alter inflammatory pathways, autonomic nervous system function, and gene expression throughout the body. The evidence is now unequivocal, states Dr. Sandoval. Your mental activity is not separate from your physical body. It's an integral aspect of your biological functioning, influencing every system from your immune response to your cardiovascular health to your gene expression. But if the mind-body connection is so fundamental, why isn't it central to medical education and healthcare practice? The implications. On a crisp autumn morning in 2018, fourth-year medical student Felicity Dawson sat in a lecture hall at Johns Hopkins School of Medicine, listening to a guest lecturer discuss a case that would transform her understanding of medicine. The patient, a 43-year-old woman named Maria, had been diagnosed with stage 4 breast cancer that had metastasized to her bones, liver, and lungs. Her oncologist had given her months to live. Yet 3 years later, her scans showed complete remission. The standard chemotherapy protocol she received typically produced such dramatic results in less than 5% of similar cases. What made Maria different? Her oncologist, who was delivering the lecture, had documented something unusual. Throughout her treatment, Maria had practiced a specific visualization technique for 4 hours daily, imagining her immune cells as an army systematically destroying cancer cells. She had also made radical changes to reduce stress, including leaving a toxic marriage, changing careers, and establishing firm boundaries with her critical parents. "I'm not suggesting the visualization cured her cancer," the oncologist clarified. "She received excellent medical treatment. But I've treated hundreds of patients with identical diagnoses and identical treatment protocols who didn't survive. Something else was happening here." Felicity raised her hand. "If there's evidence that psychological factors influence treatment outcomes, why isn't this a standard part of our medical curriculum?" The lecturer's response was telling. "Because we don't know how to standardize it, measure it, or bill insurance companies for it." This exchange illustrates a fundamental tension in modern healthcare. The evidence for mind-body integration is overwhelming, yet medical systems remain structured around a mechanistic model that separates physical treatment from psychological experience. Medical education still devotes minimal time to the physiological impacts of psychological states, notes Dr. Greenberg. The average medical student receives about 10 hours of nutrition education despite diet being a primary driver of disease. They receive even less training on how stress, trauma, and beliefs affect physical health outcomes. This gap reflects practical challenges. Mind-body interventions require personalization. They resist standardization. Their mechanisms cross traditional disciplinary boundaries, requiring integration of psychology, neuroscience, immunology, and other specialties. And crucially, healthcare reimbursement systems aren't structured to compensate providers for addressing psychological dimensions of physical health or physical dimensions of mental health. Dr. Olivia Chun, who runs an integrative medicine clinic in Boston, describes the pragmatic hurdles. "I can get insurance to cover prescribing antidepressants for a patient with irritable bowel syndrome, but if I spend 45 minutes teaching them mindfulness techniques that research shows are equally effective for their condition, that's not reimbursable." Our healthcare system incentivizes pills over processes. The consequences are significant. A 2020 analysis estimated that chronic stress contributes to over 60% of primary care visits. Yet fewer than 3% of these visits include stress management interventions. Similarly, adverse childhood experiences dramatically increase risk for 7 of the 10 leading causes of death. Yet screening for psychological trauma remains rare in treatment of physical conditions. Some institutions are beginning to address this gap. Cleveland Clinic now includes mindfulness training in its standard cardiac rehabilitation program after studies showed it reduced recurrent cardiac events by 43%. Memorial Sloan Kettering Cancer Center integrates psychological support as standard care after research demonstrated that cancer patients with depression have worse survival rates independent of other risk factors. "We're seeing the beginning of a paradigm shift," observes Dr. Chun. "It's not about replacing conventional medicine with alternative approaches. It's about recognizing that optimal healthcare must address both physical and psychological dimensions of health because they're fundamentally inseparable." This shift has profound implications beyond clinical settings. Educational systems similarly reflect the artificial mind-body division, with physical education separated from academic subjects and emotional intelligence rarely included in core curricula. "We teach children about the muscular system and the digestive system," notes educational psychologist Dr. James Harlow, "but we rarely teach them how their thoughts affect muscle tension or how anxiety impacts digestion. We teach them mathematical formulas but not attention regulation, despite attention being fundamental to learning itself." Some schools are experimenting with new approaches. Mindfulness programs in K-12 settings have demonstrated improvements in attention, emotional regulation, and academic performance. Schools incorporating movement throughout the day rather than isolating it in physical education classes show enhanced cognitive function and learning retention. The workplace represents another frontier. Companies including Google, Aetna, and General Mills have implemented programs addressing the mind-body connection after research showed that workplace stress costs American businesses approximately $300 billion annually in absenteeism, reduced productivity, and healthcare costs. When Aetna implemented mindfulness and yoga programs for employees, they documented an average productivity gain of 62 minutes per week per employee, translating to approximately $3,000 of recovered productivity per employee annually. Healthcare costs decreased by about $2,000 per employee compared to non-participants. The evidence is compelling from a pure business perspective, says organizational psychologist Dr. Vincent Torres. Companies that address the mind-body connection through stress reduction programs, flexibility allowing adequate sleep, and cultures discouraging overwork consistently outperform competitors financially. This brings us to perhaps the most profound implication. If mental states significantly impact physical health, do we need to reconsider our understanding of consciousness itself? Mainstream scientific consensus still largely views consciousness as an emergent property of brain activity, something that arises from physical processes rather than something that might influence those processes. Yet the evidence for bidirectional influence challenges strict materialism. We're comfortable saying that physical brain changes cause changes in consciousness. That's the basis of psychiatry, notes neurophilosopher Dr. Rachel Woods. But we're less comfortable examining how consciousness influences physical processes, even though the evidence for this direction of causality is equally robust. This discomfort reflects deep philosophical commitments in Western scientific tradition. The methodological materialism that has made science so successful at explaining physical phenomena becomes problematic when addressing consciousness itself. Science assumes an objective observer studying physical processes, explains Dr. Woods. But consciousness studies require the observer to observe their own observation process. The subject becomes the object of study, creating methodological challenges our scientific tools weren't designed to address. Some scientists propose that these challenges require new investigative approaches. Neurologist Dr. Gabriel Harrison suggests, perhaps studying consciousness requires methodologies that combine objective third-person measurements with systematic first-person phenomenological reports. We need both the view from outside and from within to fully understand a phenomenon that straddles that boundary. This perspective helps explain why contemplative traditions like Buddhism have sophisticated maps of consciousness that Western science is only beginning to validate. These traditions developed rigorous first-person methodologies for observing consciousness, complementing the third-person methodologies of modern science. The most promising research doesn't try to reduce one perspective to the other, says Dr. Harrison. It looks for correlations between subjective experiences and objective measurements, acknowledging both as valid data streams for understanding reality. This integrated approach is yielding insights that neither perspective alone could generate. Studies correlating meditators' subjective reports with brain imaging have identified neural correlates of specific conscious states. Research on psychedelic medicines is mapping relationships between chemical changes, brain network activity, and profound alterations in subjective experience. What's emerging isn't dualism or pure materialism, concludes Dr. Woods. It's a perspective that sees physical and mental phenomena as different aspects of an integrated reality, complementary rather than contradictory ways of understanding human experience. This perspective suggests that the mind-body connection isn't merely about one physical system, the brain, controlling another, the body. It points toward consciousness and physical processes as interconnected aspects of reality that mutually influence each other in ways we're only beginning to comprehend. Final insight in her rehabilitation center office, Felicity Dawson, the woman who walked again after being told she never would, now works with patients facing similar prognosis. On her desk sits a framed quote from pioneering neuroscientist Santiago Ramon y Cajal. Every man can, if he so desires, become the sculptor of his own brain. The most important thing I tell my patients isn't about specific techniques, Felicity explains. It's about understanding that your body is constantly listening to your mind, and your mind is continuously responding to your body. They're not two separate entities but aspects of a single, integrated system engaged in constant conversation. This conversation happens whether we're conscious of it or not. Every thought triggers neuropeptide release that affects cells throughout your body. Every gut microbe produces compounds that influence your brain function. Every movement alters your brain structure. Every belief shapes how you perceive and respond to physical sensations. Becoming conscious of this ongoing dialogue represents perhaps the most powerful intervention available to us. When we recognize that our mental activities aren't isolated within our skulls but reverberate through our physical bodies, we gain access to healing capacities that conventional education rarely addresses. This doesn't mean we can simply think our way to health. The mind-body connection works within biological constraints. No amount of positive thinking will regrow an amputated limb or cure advanced pancreatic cancer without medical intervention. Psychological approaches complement rather than replace appropriate medical treatment. The real power comes from integration, says Dr. Greenberg. When we combine the best physical interventions with the best psychological approaches, we consistently see better outcomes than either approach alone could produce. This integrated perspective challenges us to reconsider fundamental aspects of how we structure healthcare, education, and society itself. If mental and physical health are inseparable, then addressing only one dimension will always produce suboptimal results. If environments and relationships affect gene expression, then health becomes a social and environmental issue, not merely an individual one. If beliefs shape biological responses, then the stories we tell about illness and wellness matter as much as the treatments we provide. Perhaps most profoundly, this understanding invites us to reconsider the nature of consciousness itself, not as an epiphenomenon produced by physical processes, but as an integral aspect of reality that dynamically interacts with those processes in ways that materialism alone cannot fully explain. As we navigate the practical and philosophical implications of these discoveries, one thing becomes clear. The conversation between mind and body isn't just happening within individuals. It's happening across scientific disciplines, between traditional and contemporary healing approaches, and throughout human culture as we reconsider what it means to be embodied conscious beings. The boundary between mind and body, it seems, was never a fixed wall but a permeable membrane, a dynamic interface where thought transforms into matter and matter shapes thought in an eternal dance of mutual creation. In recognizing this dance, we don't just discover new therapeutic possibilities. We glimpse a more complete understanding of what it means to be human, not divided selves of separate mind and body, but integrated beings whose every thought, emotion, and belief is simultaneously mental and physical, subjective and objective, personal and universal. The mind-body connection isn't just something we have. It's what we are. Consciousness embodied, matter animated, the universe aware of itself through the miracle of human experience.